Okay, so for these cofunction identities and the even-odd identities, these are not given in your formula booklet, but these are really easy to figure out thinking about the unit circle and thinking about triangles. So notice that if I have a right triangle, so if I have some angle here, theta, and this is my right angle, so in radians it's pi over 2. So I know that if we make this angle phi, so phi plus theta plus pi over 2, that's my right angle. That all has to add up to a total of pi. So these are angle measures. So remember 180 degrees is pi, 90 degrees pi over 2. That means that phi is equal to pi minus theta minus pi over 2, which is pi over 2 minus theta. Well, now, if I think about having sides of this triangle, I'm going to move it up a little so I can add some to it. If I have sides of x, y, and the hypotenuse, then looking at this, I could say cosine of theta. So according to my triangle here, cosine of theta is x over h. Sine of pi over 2 minus theta, well, pi over 2 minus theta is my phi. So sine of phi is also x over h. So you don't have to memorize this identity. You need to be able to think about a triangle and how within a triangle, the cosine of this angle is the same as the sine of this one. And we saw that all over our unit circle. So for pi over 6, the sine value is a half. For pi over 3, the cosine value is a half. Well, pi over 2 minus pi over 6 is pi over 3. So that's what all of these identities are. And we can deduce them by making triangles and thinking in terms of angles. So instead of thinking of phi here, thinking of this angle as pi over 2 minus theta. And then we can find all of these relationships so that they're all true. Sine of theta would be y over h. Cosine of pi over 2 minus theta is y over h. They're all true. Tan theta is y over x. Cotan, remember cotan is going to be so where tangent is opposite over adjacent, cotangent is adjacent over opposite. So adjacent over opposite. All of those are true. I'm going to make a separate video for even odds.